Now welcome back. The next topic is for again class 11th and 12th, which relates to decrease in carbon. In my previous video the other day, yesterday, we talked about increasing the carbon. Now today we are going to talk about how to decrease the carbon, right? So you can say, sir, is it valid on alkene? Is it valid on alkyne? The answer is capital yes. See how. This is alkene. It can be reduced. Sorry, alkyne can be reduced to alkane, alkene in presence of nickel at 300 degrees centigrade, and alkene, that is He, can be reduced back to alkane. From here, ethane to methane, or for that matter, ethyl chloride to methyl chloride, or for that matter, ethaneal to methaneal. Next can be ethaneol to methaneol, or this way. The concept remains same. Alkane can be decreased to one carbon and then can be made to undergo free radical substitution reaction to give chlorine. So the question today we have selected is ethane to chloromethane. Let us see. The question we have selected is ethane to chloromethane or methyl chloride. Chloromethane, and this is ethane. Again, we'll have 6 methods. How many methods for decreasing the carbon do we have in our packing today, in our box today? 6 methods. So we will talk in terms of Roman 1, 2, 3 and 4. And for the records, allow me to say that few of them, 3 to 4 reactions would be name reactions. So you can keep on relating the name reactions also when you increase or decrease in carbon. So to start with, let us convert ethane to ethanol. Under controlled oxidation, that is oxygen under heated copper at 200 degrees centigrade, ethane would oxidize to ethanol. Now from ethanol, we can bifurcate to 2 methods. Number 1 and number 2. Number 1 is active hydrogen method. In this, we take Grignard reagent with 1 carbon. You can see this is electronegative, this is electropositive, this is electropositive, and this is electronegative. So this results into formation of methane, and the byproduct is magnesium ethoxybromide. You can keep on putting your questions also in case there is you might as well have, sir, you have given a flow chart, but we are more comfortable with the reactions. So that is not an issue. Your comments are more than welcome. If at all you would say, sir, it is better to have reactions, so I will make another video in which we will only talk in terms of reactions. We will not talk in terms of flow chart. But flow chart is according to my belief, flow chart is a very good method to increase your muscle memory because you have it everything on one single page. That is why I prefer flow chart. And I also recommend you as students to go through flow chart first and then start working on reactions. Further again, in this method, if you put concentrate sulfuric acid at 170 degree, the water will release out, it is dehydration. Now, in terms of previous knowledge, dehydration is removal of chemically combined water. What is dehydration, children? Removal of chemically combined water. Now, with this dehydration, alkene you made to react with ozone, which converts to ethylene ozonide. Ethylene ozonide oxygen looks like this, and both the bonds are clean. And when you further reduce it with zinc and hot water, both these bonds break, resulting in formation of peroxide and methanol, 2 moles. Now this methanol can be reduced to in nickel at 300 degrees centigrade to methanol, and methanol can be made to react with PCl5 giving methyl chloride, phosphorus oxychloride and hydrochloric acid or hydrogen chloride are the byproduct. Or you can reduce alcohol to give methane, and methane can undergo free radical substitution reaction with chlorine to give methyl chloride, and this is what we want. So there are two methods we have done. One, active hydrogen method, and I told in the previous video also, active hydrogen method is not valid beyond 3 कार्बन. 3 कार्बन से ऊपर एक्टिव हाइड्रोजन मेथड नहीं चलेगा. प्रीवियस वीडियो में भी मैंने बताया है. In this case, we are dehydrating an alcohol to alkene. Alkene react with ozone to give ozonide product, and ozonide when made to reduce under zinc with water, it gives aldehyde with 1 carbon. That is, both these bonds are cleaving. Now aldehyde can be converted to halide like this. In this case, third one, first of all, let us oxidize uncontrolled oxidation of alcohol to acid. Now, uncontrolled oxidation of alcohol or alkane or aldehyde always results into formation of carboxylic acid. Now, for the remaining 4 reactions, we will talk about decrease in carbon with few name reaction. Number 1, SMID. In this, it is made to react with hydrozoic acid to give amine followed by carbon dioxide and water. Amine can be made to react with nitrous acid to give alcohol, and alcohol can be converted back to halide like this. Second is when it is made to react with ammonia, it gives ammonium salt. Acid with base gives salt. When it is dehydrated, it gives amide. And amide when made to react with bromine and KOH. This is Hoffman degradation reaction. This is Hoffman degradation. Name reaction again. Hoffman degradation reaction. This results into formation of primary amine, that is methylamine or aminomethane, and aminomethane then can be converted back to chloride like this. This is number 1, 2, 3 and 4. We are remaining with 2 more. In this case, we react with silver hydroxide. This converts to silver salt of carboxylic acid. This made to react with bromine in presence of solvent. It converts to methyl bromide, and methyl bromide with aqueous OH, KOH converted to methanol, and methanol can be further converted back to halide. This reaction is called Huns-Dicker reaction. Again a name reaction, Huns-Dicker reaction. And third one is very simple, which you have studied in preliminary classes of 9th and 10th, any board, UP board, CBSE board, ICSE board, that is soda lime decarboxylation. Acid made to react with base to give salt and water. Salt and water. And this made to react with soda lime with heat it gives sodium carbonate as byproduct followed by methane. And methane can be converted in chlorine with UV light free radical substitution reaction to give methyl chloride. So summing up, alkane to halide we have to make with one carbon less. There are 6 methods for converting a decrease in carbon, that is from bringing about 2 carbon to 1 carbon or 3 carbon to 2 carbon or for that matter so on and so forth. Earlier in the previous board I told you alkyne can be converted to alkene, alkene can be reduced back to alkane, and ultimately alkane can be further testified or further treated with the required reagents as the case may be. So let us revise once again. Pehla, first method is active hydrogen method, second method is reductive ozonolysis method, third method is soda lime decarboxylation. Soda lime decarboxylation, this is third method. Fourth method is Huns-Decker reaction. Fifth method is Hoffman degradation. And sixth method is Schmid reaction. Now in this board you can see you have done two name reaction. Schmid, Hoffman degradation, and also Schmid is this. So you can write this method is Schmid. And if you relate with increase in carbon, we had done only one, that is Wurtz. So we have in total, among decrease and increase in carbon, we have done 4 name reactions. For increase in carbon, we talked about Wurtz, and for decrease in carbon, we talked about A. Huns-Decker, B. Hoffman degradation, C. D. Fourth one is Schmid reaction.